Maybe just to make use of time, well, I think we might be getting Thomas. Uh, I think we've got probably some work to do as a community to start like standardizing on Intel's PoE proposal, or building some sort of common approach there for being able to identify hardware. I don't know if that's a topic that's well suited for this SIG, or if we want to spin up a different working group for that sort of thing. If people have views on that.
I'd personally love to see that entire um, specification or doc discussed. I mean, it's relevant, to the work I'm doing for a few different reasons. But I think that's a big meaty topic. So, and it has to obviously has to be supported by somebody who's authoring it, caring or providing time and energy to present. But I'm certainly interested.
Well, we did present, well, Benny, if you recall, a few sessions ago on the
Hmm.
POE. There have been some updates since then. I think at that point he described
Hmm.
the overall POE and the tools that were available at that time. But since then, we've published more like a CORIM profile and
Yeah.
additional tools for generating and processing uh, the POE, the evidence, and the CORIM.
Yeah, I think since then, I guess I've just gotten more um, better understanding of the whole area. So, um, but yeah, that's no
Yeah, and
reason
I think,
to subject everybody to it again, just because I figured a few things out.
well, yeah, and I think it needs to go beyond like a presentation. I think the agenda to be resolved is we need to make sure that like all of the CC silicon manufacturers feel like that's something that can be supported, or some variation that we can work towards, and that all of the CSPs, NCPs, so forth, anybody who's going to be hosting that hardware feels like that is like an API that they can present. So I can imagine like a series of discussions where we work towards both of those aims, that everybody who's making hardware feels like, yeah, this is a good solution that we can all support equally, and that people who are presenting hardware that are hosting it feel like that's something that's worthwhile for them to advertise and maintain.
And when we're talking the POE endorsement,
Right.
okay.
But I think, generally beyond that specific presentation, or that specific proposal, the idea is to be able to
I, I guess
know
I
that you're.
I guess I don't quite understand the question because or what you're after. Because the POE endorsement, as I understand it, is an Intel suggested way to express whoever owns a Intel CPU, a standard way to express their ownership, perhaps by a CSP or some other entity. And
Mhm.
it's Intel specific. And as I read it, it was not like I didn't read it as suggesting that this is the schema or the pattern that should be adopted by other um, identifiable attested environments that need to have some sort of or might benefit from an ownership kind of endorsement. I'm not as the ask that, hey, are the folks that do want to express ownership, or is this going to work for them? Or is this an ask of, hey, other folks who might want to support ownership, are you able to see how to go from here to there in terms of applying this pattern to your circumstance?
Yeah, and now that we've got Thomas, I don't want to take up much more time, but the idea would be, yeah, I want to go rent hardware from Azure and Google and whoever else out there, and I want to be able to know that I'm interacting with the hardware that I intended to. So I need to know that, is Azure happy to support that API? And then similarly, I might want to, have a common view of any kind of confidential computing hardware. So, I mean, is it really Intel specific, or is it a good general purpose format that any silicon vendor can support?
Yeah.
Yeah, I don't quite understand that. If I put it to S&P as an example,
Mhm.
I thought the platform ownership endorsement was broader than the specifics related to the confidential compute offering on, for instance, an Epic CPU product. So I don't, I'm not quite clear why extending S&P to actually bring up a PoE through through the ABI surface actually provides any additional security value from that perspective. I think it may be valuable to have a platform endorsement, um, kind of in a more supported in a more general sense, but not necessarily specific to the confidential compute offering. Like take for instance, I mean, I can't say exactly, but works the same way with TDX. S&P doesn't have to be active at any given instant in time. I mean, you can still use an Epic CPU and a platform ownership endorsement. It's still applicable, right?
Mhm.
So,
So what I get from this is clearly we have some things to discuss. So maybe we
sure.
can pick that up and figure out what a good common strategy is here for the consortium. Meanwhile, I've tap danced a little bit for you, Thomas. I don't know if you are prepared to be able to pick up where you left off last time, or if you would like me to do more dancing.
I'm not entirely prepared, so and it also looks as though we are a bit short on numbers here, but I'm not sure. So I wonder if we should postpone until next time. Otherwise, I can resume from where I thought we were. But I'm not sure. I need to ask you for confirmation about the state of the presentation last time, because I went on holiday and basically got a frontal lobotomy. And but you know, I can if you are really keen on listening to someone blabbering about Quorum for the next 30 minutes, I'm more than happy to try and resume from where we were. Otherwise, as I said, I can prepare better and restart next time with a bit more. But
Well,
yeah,
I
it's
wouldn't
only
let the attendance affect your discussion, because I think a lot of people will come after the fact to watch the recording. So if you think you can make a cogent presentation today, I think that would be the main decision criteria. If you just, you just back from vacation, you weren't prepared to do this, it's totally fine to punt, but I wouldn't let the numbers here dissuade you if you think you can kind of get into the rhythm.
I can try if you are happy for me to do that. I can surely try to put something together.
Well, I
Same
know
goes
we
for
didn't
everybody
get
else. You can ask, everybody else can ask, leading questions.
I know that you didn't get through your previous presentation. I'm not exactly sure where we ended.
We left off around slide 10, if I remember correctly. I was just scanning through the slide deck and trying to recall where we left. I think it's when we started looking at the quorum and commit from the 10,000 feet view, right? So from the envelope perspective. Is anyone, so for who's there? Greg, we were there, Giri, yes.
I don't remember exactly where we left off. I do recall that, we were just in the middle of it, and there was still plenty more, was my recollection. So
Yes, yes, exactly. I think I was one third through the slide deck. So which makes, the slide 10, slide 11 a plausible number for me to restart from.
Yeah, from my notes, you were talking about the workhorse triple for reference values, and you had an example of like Gizmo from Acme.
All right, okay. Excellent. So we were quite far then. Sorry, we were then around slide 18, much better than I thought. Cool. Okay, so we did the triple subject predicate object. We did the MTI versus OTI, the environment map, the measurement map. I didn't. I was on holiday. I really forgot everything. Okay, so now reference values. The discussion on acceptable state, right? We did it, and then so if we are at the example, which is
Sorry,
like,
Thomas, is it possible for you to share your screen already? Or are you
yeah,
still organizing?
I was sure, Nathaniel. I will do that shortly. Share Corim 101. This one. Do you see what I?
Yeah,
Do you see
that's
the
good.
page with the
It
yellow?
helps me keep
Okay.
track of where we were too. Yeah, I see.
Okay. So we can move on from here. Target environment is made by Acme. Okay. So this is the reference value triple, right? So we have, and this is a seaboard diag or a seaboard EDN, as they call it these days. So we have the subject, which is the environment we are dealing with. And this is expressed as a class environment, right? Using the UUID. This is an object made by some vendor Acme, and the model of this attester is Gizmo. There's nothing weird here. This is what we are talking about, which thing we are talking about. And the measurement map, which is the claims about this which thing, is collapsed at the bottom of this. And I think this means that I will explode it here, right? Because now the measurement, which is the claim, we're saying this environment, so this UI Acme Gizmo environment has a known good value, a SHA-256 digest, which is DA blah 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 E1. So if you want to read this whole triple as a sentence, you need to visualize it as the Acme Gizmo is expected to have this SHA-256 digest expressed here in terms of X dump. And this is the reference value. And if the device evidence reports that same digest, then this is corroborated, right? So this the value is corroborated, and if it reports something else, then that's a red flag for the policy. And purely so, we believe that that's real and concise, right? Quorum is concise rims. Here's the actual seaboard bytes for that reference value triple, which is basically 3 lines of hex. That's the whole triple on the wire, and this is pretty concise, I would say. But moving on. So this slide here, how it's processed, is basically the bridge from the data model to the quorum processor. So we need to probably slow down a bit here. So here you see the transform function, which is how a reference triple becomes an internal object that the processor works with. And this is called the RV item in section 8 of the quorum draft. And notice that the RV item in question has 2 halves, a condition and an addition. You can see that I don't have line numbers, but if you scroll to the transform function, you will see the actual attributes, condition and addition. The condition is built from the triple. It has the same environment and the ref claim become the condition element list. This is it. What do I need? What do I match against evidence, right? And the addition part also gets the environment, of course. The CM type is set to reference values, and the authority is set to the quorum signer. which is the reference value provider. And there's a crucial subtlety at the bottom of this slide that says that the claims are not copied as is into the addition at transform time. Why? Because the condition might be a range. Represented as a range, right? So an int range or a set of values. And we don't know what the device's actual value is until evidence matches. So we wait, right? So we don't stash anything in the addition. And when match happens, then what we do is we copy the mesh value across. Only the mesh value, not the entire range that was possibly encoded in the condition. So this is a bit of a key point in the thing because it becomes the bridge to the actual query processing part, which is slightly. This is like a bit more complicated, I would say, but there are some core principles that if you grasp them, then is not problematic to understand the rest of the processing across the whole triple set. Right. So just as a TLDR, the pattern to carry forward is that every reference value becomes a condition addition pair, and so that is true for other triples that we will see, like the following one that I wanted to show you, which is the endorsed values, right?
Hey, Thomas, you mind if I just add a clarification? So when we say claims are added to the ACS, also there's evidence that could come in come in, for instance, the endorsements, like in the dice chain, and that can also get added to the ACS as well. But that would have to actually be transformed. So, I'm talking about, like, for instance, the TCB info fields in a dice certificate that can be extracted at the verifier end and compared against a quorum. So.
That is correct. So
yeah,
that is though part of the quorum processor is the initialization of the quorum processor, where the ACS is pre-filled with the transformed evidence. You're correct, right? So you have dice evidence that is TCB info extension. You need to extract that at ingestion time, transform it into something that looks like an internal quorum data structure, in that case, the AE item, and then stash that thing into the ACS. And that's what basically bootstraps the condition addition algorithm. But I will show that later on. So if you're patient, I will go through the data model first, and then sort of
sure.
talk about the dynamics of the thing. I wanted to introduce here the transform because it sort of creates this kind of bridge, but you're moving a bit too fast for what I had in mind.
Well, I just wanted to kind of get the audience to know that attestation evidence can also appear in endorsements, and the quorum that's been defined still takes care of that. It's still suitable.
Yeah, correct. All right, so moving on to the endorsed value triple. This is the endorsed triple record. Is a condition environment plus an endorsement that is represented as a list of measurements, and the difference from reference values is semantic, right? Structurally, they are very similar, but while reference values are things you check evidence against, endorsed values are things that the device can't report about itself, but that the endorser vouches for. So, for example, a certification status, provenance, a security rating, these kind of things. And it's sort of unconditional-ish in the sense that it's keyed only on the environment. So if the verifier believes it's looking at this environment, then the endorsed claims get added under the endorser authority in what we call phase 4 during the processing algorithm. The interesting thing is that no evidence needs to corroborate them because by definition they are not in evidence. So they are slightly different from ref values from that perspective. But if you could also frame the thing in terms of corroboration, right? Reframe it in terms of corroboration. If you think of the process of verifying the cryptographic signature over evidence as a sort of corroboration that happens before the quorum processor starts. So in that sense, conceptually, they might be more similar than I'm trying to make here. And again, an example here, same Acme Gizmo environment, the endorsement, in this case asserts that it is version 100 with security version number 1. So if a relying party's policy cares about the fact that whether this device is at least SVN1, that fact can come from an endorsement, even if the device's raw evidence never carried that version at all, right? And that's the power of the endorsed values here. So the endorser is the role in the RATS architecture that fills this gap. And again, that's the whole value of endorsed values, that enrich basically the picture beyond what the silicon can self-report. And then the third MTI triple, and I believe the most powerful, is the conditional endorsement. And this is basically an endorsement with an if built in. The triple has two parts: the conditions that are a list of so-called stateful environment records, and then the endorsements. And a stateful environment record is an environment plus an optional claim list that describes the state that device must actually be in. And the semantics of this thing is that basically if all the conditions expressed by the triple are corroborated in the device's actual state, then the endorsements part of the triple is added to the ACS. So unlike the plain endorsed values that I was showing you before, these are gated on what the device actually reported. So the classic use of this thing, it might be that if this component reports firmware digest X, then it is known to be version 2.0 and have a property Y. You can't state that unconditionally because it's only true for devices in that specific state. Right? So the conditional endorsements is the sort of the construct that lets the endorser express facts that are state dependent. And this is the triple that makes quorum expressive enough for real messy kind of supply chains. And here again is an example that says basically if Acme Gizmo has measurement digest DA.E1, and that's the conditions block, then it has version 1.0.0 and SVN1, and that's the endorsement block. So the top half is the top half is a condition that will be matched against the ACS and the device actual state, and the bottom half is what gets added only if that match succeeds. What should I say? Yeah, it's basically structurally this has the same environment plus claim shape that we have seen all along. It's just composed, right? So conditions are environment plus claims and endorsements are environment plus claim. The same sort of Lego bricks, but a richer assembly here. And notice it sets up exactly the conditional addition pattern that we saw with reference value. So that's not a coincidence. That it's sort of the topic of the processor half of the talk. Okay, then moving on to If there's any question, please feel free to interrupt me because I don't see the screen, the Zoom screen here. I only see my presentation.
Hey, Thomas.
Hello? Hi,
Yeah,
Greg.
yeah. I have it's not specific to any of the slides, but for me, it's kind of a fundamental get my head wrapped around CORIM question that I would like to ask, but I'll leave it to you as to when it's about the measurement map and some details in there, which is I think like environment and measurement map. Those are the two most important structures as far as I can tell to understand about CORIM.
Mhm.
And so I have a basic question about measurement maps. So just tell me when's a good time to discuss that, um, and I'll happily ask the question.
No, no
All right.
problems. Yeah, so the
So
slide 15 has I brought up the slide 15 with the
yeah. Thank you.
CDDL if you need it.
Yeah,
to-
thank you.
to-
This is perfect. So from what I've seen, right, so a measurement map represents in my head a key value pair, and you can do the key, the M key, and then M val for the val. But I've also seen, since that M key is optional, and I've seen folks use like no M key, and then the kind of key value pair is by picking one of the components of the measurement values map, like for example, digest for a firmware hash code or something. And so like when like if you're a tested environment like has two firmware hash codes, then you kind of like you have to kind of, I think, say, okay, I'm gonna have to use M key to distinguish, firmware hash one and firmware hash two for the, two different functional purposes. But if I just have one firmware hash code, I may just put it under digests and not have an M key, value in the measurement map wrapper. So I'm trying to get, I think kind of like is the intent of like, the things I see down there in measurement values map, version, digest, SVN flags. I sometimes seen them used as like, oh, this is a data type. So if you have like a measurement that's, a digest, then use the digest. If you have a measurement that's an SVN or something, use the SVN. And other times I see it used as like, oh, I have this thing, it has one of these things, so I'm just using, like SVN as the SVN. And to me, that's what I see, and perhaps I'm just looking at that, poor examples, but it's very confusing and it makes it kind of challenging to both understand and then to write the code to just kind of, so what's the intent here?
So if I understand correctly, Greg, then correct me if I'm wrong or I'm going on a tangent. You're asking what is the value of M key and when and how I should use M key. Is that
Oh,
the
or you can phrase it as forget M key for a moment. Are those things version, digest, SVN, and flags for this thing here? Are they semantically, should I think of them as data types? So like I have a measurement and these are available data types to choose for like expressing my measurement, maybe, yeah. Or are they semantically like kind of suggest what the heck they are? Like this is a SVN for my attested environment. It seems to me like they have to be data types because
yes,
in any attested environment, I can have lots of SVNs and lots of digests.
yes, they are data types that you can pick and choose, and
Okay, so
basically
okay,
the namespace. So the thing that they are attached to is something that needs to be named, and the namespace for that something is defined at two levels: the environment level with the class instance or group IDs and all that kind of things, plus an optional namespace level just below the environment, which is represented by the M key, right? And the M key can identify, say, a subcomponent within an environment, or could specify, say,
yeah,
the name of the measurement if you want to give explicit names. So you could use it in sort of two ways, but in abstract terms, it's really naming a naming device that you have at your disposal to create to name the things that you are measuring, that you are attaching these data types to. That's the thing.
So the M key is to name the thing I'm measuring, but it's part of a composite name, which includes the environment. So if I consider it fully qualified from the environment, I can skip the M key. If I don't consider it fully qualified from the environment, I should include the M key, correct?
Correct.
Okay. And
That's
why isn't there a data type that's basically a string? There's a name, but there's not a string. And the name is defined to say, this is the name of the attested environment or something like that, you know? And I struggle with that. I have scenarios where I just want to basically have a string and I don't have one, and I'm left to like do custom, extensions of CoREM. There's two strings. There's the name, and then there's like another one, but neither of them is just like a generic like string.
So you want a generic string, or you want a type that doesn't exist in the map currently?
Both. This map is not complete. And if you do the full thing, there's two different ones that basically on the right-hand side point to TSTR. One of them is called name and the other one's called serial number. I like when I'm doing an endorsement, I want to endorse something, and conceptually it's like it's a claim name of my own flavor, like Greg Super Duper Checked, that's the claim name, and the value is true. So here in the measurement values map, I imagine putting like the M key as Greg Super Duper, claim name, but then for the value, it goes into this values map. It's not really a name. It's not the name of the attested environment. It's not a serial number. I just want to, the data type I want is string or TSDR, and I'm left to basically go and add an extension or abuse the name, which is what we're doing at the moment. We're abusing the name one in there, saying, well, it's a TSDR. It's the most generic thing I see. And
oh, that's bad.
Yeah, I figured so. So,
and yeah, what I like to understand, maybe we take this offline, is the semantics of the things that you want to express are really something super mega custom, right? Like super duper Greg.
Well, it's just like when we're adding, like for my scenarios, when I'm adding endorsements, we're typically doing name value pairs where the name is a string and the value is a string. Like Azure certified or Azure certification, category. And then the string will be Azure super certified, Azure medium certified, Azure not certified, right? So it's just, it's when I'm doing endorsements, not so much when I'm dealing with evidence and modeling it, but when I'm adding an endorsement, it's typically, it's a name value pair where.
So let's make this a requirement for the measurement value map, because these are types, and string is a type. So if we want to encode the things that are just strings without further qualification, then we might want to add a string type directly into the measurement value map, and not have to go through the extension route, which doesn't seem like the right thing to do for such a basic use case, right?
Okay, cool. Do you want me to add an issue on the CoREM?
Exactly.
Repo?
Yes.
Okay.
Yes, please.
Cool. Thanks.
Thank you very much. All right. Moving on.
Gary has his hand up.
Yeah. So this is kind of more for you, Greg. So if the M key, the M keys and the corresponding M valve, I assume would, from a practical perspective, would come from the SoC manufacturer. So they wouldn't necessarily have room for an endorsement from a third, from somebody like a CSP. Then now the CSP takes advantage of the quorums with the appropriate M keys and M valves for a given attester environment, based on when the information the manufacturer provides it. Are you saying that measurement map needs to be endorsed by the CSP, like Microsoft Azure, before it can be used in a verification service, also administered by?
No. What I'm saying is that so first I find it shocking to if I interpreted you correctly, maybe I didn't, but my model of the world is anybody's free to endorse anything. And CORIM is a mechanism, that one can express an endorsement.
Mhm.
And in running a cloud service and implementing end-to-end confidential or confidential compute scenarios that benefit from remote attestation, it turns out, at least like in Azure or at least in Microsoft, there's lots of parties that basically have lots of things to say about this end-to-end system. And the manufacturer of the TEE may say things about the parts that they own. The different parties, like in Microsoft or Azure, may say things that kind of conceptually um, uh, um, are based on that, but then extend it or say this is, like the manufacturer may say this is, what is currently secure or secure on date, X. And Azure, for operational needs reasons, may say, well, at the moment we have a slightly different perspective, and maybe we'll say, go back 30 days. That's from the manufacturer's endorsement perspective. It's like we're running 30 days late, and so just whatever the manufacturer said was cool 30 days ago. That's what maybe there's an endorsement from Azure like that. Not saying there is, but maybe. And then there's different then there's measurements in the evidence that are measurements that are things like controlled by not the hardware manufacturer, like measurements of the initial measurements for like booting a confidential VM. And so there may be those say measurements of the BIOS or the HCL or the initial disk image or something. And so there are parties, let's say within Azure or Microsoft, that manufacture those things, are responsible for them. And they may generate endorsements saying, yes, this is a blessed image or not a blessed image, or it was blessed yesterday, but not today. So there's, endorsements are of all the things that are measured, there's different authorities that are, authorities over the different types of measurements that go, I guess, once you kind of get through the hardware and
Mhm.
start crawling through the stack of software that's kind of running, from boot up to, as things are launched, there's different parties eventually, from different places that may say things about that. CORIM seems to be the
Yeah.
reasonable way to go to do that. That's where my head's at.
Yeah. Okay. That makes sense. So, sorry to speak for you, Thomas. Thomas is presenting the standard as it's being developed in the IETF. But from an operational perspective, you may take, for instance, a raw quorum from a vendor like AMD or ARM, and I call it raw quorum. It'll be specific to an attester environment that AMD produces, like S&P dash Epic or something like that,
Hmm.
and it will have M keys and M vals um, specific to that product as well, and it'll be signed by AMD because it's a COSA data structure. Now, Azure can ingest that quorum, and it can extract those values and it can reproduce them into form of another quorum which is fully endorsed by the various parties that you mentioned within
Hmm.
Microsoft. So
Hmm.
that's perfectly allowed. It's just that if you go to the standard, you're not going to get that aspects of the operational model necessarily corresponding exactly to what you need to do within your
Hmm.
organization. So yeah,
Hmm. Yeah. I think
okay.
the most succinct example for the scenario I was going through with Thomas for like my example endorsement. So when we boot up our confidential VMs, we have a measurement both in TDX and SEV-SMP of essentially the hypervisor that's running the VTPM. And we have like an endorsement of those measurements. And those measurements are like the launch measurement in, I think, SEV-SMP, or it's the launch measurement for both those two environments. And and based on that, we'll basically say Azure compliant CVM or not. And that's a string, just that's a name value pair that's string. Azure compliant CV or MS compliance XS MS compliance status for the name, and Azure compliant CVM is just an example string for the value. But yeah, the measurements we're using are ones that are based on, components that we deliver as part of how we, run the Azure fleet. We're not typically remarking or overlapping with the co-rem fields that are being commented on or being put into reference values or endorsements by the hardware vendor typically, but on occasion, I imagine we might.
All right, thanks for the explanation.
Thank you.
Thank you, Greg and Giri. Is there anyone else that wants to ask questions?
So Thomas, I have a question on the conditional endorsement triples. So you gave
Sure.
an example where you basically said that you can add additional endorsements, right? For example, based on the hash, you can basically endorse the version through
Correct,
this endorsement triple. You also mentioned there's an and condition. So basically, like, can I also do this, that I can say that when firmware A has a hash of X, let's say, and firmware B has a hash of Y, then my package is Z, right? Like something like that, something like this. And then it's an and condition saying that when both the conditions match, then I'm having this endorsement.
That is correct. So the condition is an array of the conditions, right? So then all these conditions are taken in AND. So
Okay.
if all those things match, then you add an endorsement.
Okay.
The multiple endorsement, because endorsement is also an array, so you have the ability to do multiple assignments in one go, basically, with one triple. So if the question was, is the condition semantics an and between the variables? Yes, the answer is yes. Correct. You're correct.
So I think this is really useful because basically, like in the measurement map, you put individual claims about the measurement, and then at the package level, let's say when you're releasing a package, you can basically create a conditional endorsement claim saying that if these measurements are these, and then I endorse this as a package, right?
Yeah, exactly. You can create higher level claims about an aggregation of things. Yes, correct. That's the power of this triple.
Okay. Thank you.
And
Thank
those
you.
are, you said those are implicitly ands. They all have to be true.
Yes.
Okay.
Correct me.
Thanks.
Thanks, Greg. Do you want to ask another question, or I can move on?
I think that's it. Thank you very much.
Good. Right. So I think we were here, right? So very briefly, because that's you so that you know what's waiting in part 2 of this. Whenever I get to that part 2, but these are the optional triples that we're going to see. The conditional endorsement series that are sort of chain conditions with a special matching algorithm. The identity keys, the attestation keys, which are sort of the cryptographic material for identifying devices and verifying evidence integrity. Then the domain triples, the trust dependency and domain membership that allow you to describe composite multi-component attesters and the relations between the various components within this composite blobs. And finally, the
Hey, Thomas.
Yes, Greg.
I know you're looking at this. Where do I go to make a case for conditional endorsement series to become required? It's like every bit of work I've done ends up using it. So
Is it?
yeah.
Okay. I've never heard anyone.
It's like at the end of the day, it's like we eventually get to some path in our design. We like, okay, conditional endorsement series, here we go. So
Okay, excellent. I will ask
I guess I shouldn't
you-
say every, but it's very common. It's like for me the ones that we do are the reference values, the endorsement triple, the conditional endorsement triple, and the conditional endorsement series triple. Those are the 4 that so
Okay.
far cover everything, and we're pondering whether and how to do keys, whether it's attestation keys or the whatever that other structure is out there. But
Okay. So just for, just that you know, I'd like to ask you then to review a specific section that describes the processing of this conditional endorsement series and see whether that matches your understanding of the thing. Because
It does, because that's exactly how I implemented it.
okay.
Exactly. I mean, it's in production right now.
All right, excellent. That's very good news. Because my fear was that it was not implementable, but if you say it is, then
Well, maybe
Great.
there's a bug, maybe I did it wrong, but it was it was the order thing and stop on first match was,
Mhm.
worked great for what we were doing. So
Great, excellent. Right, okay. All of these are sort of useful, as Greg says, maybe more useful than I thought before, but none of this is needed to understand the core of what I'm going to describe later. So we can park them safely for now and move on to the coring processor. That is how does reference state meet actual state? Basically, this is where what we call the reconciliation process happens. Basically, how do all these triples that we have discussed get consumed to produce the verdict about the device, the attestation result, right? Finally. Okay, so we can move to the processing flow slide, and here's very proud of this picture. It is one of my ASCII art masterpiece. So and you have this the whole machine is in one slide, and so let me trace the data through it. It's for taking that a bit slowly. So you have two inputs that enter. On the right, you have the quorum files, the reference values, endorsement, and whatnot that get validated, and then they are transformed into the internal representation via the transform function that I showed you before. And then on the left, you have the other input, which is evidence that comes in and is validated and transformed the same way. And that's what Giri was anticipating before. And then the transformed quorum items land in the so-called staging area, which is basically the holding pen of things that are waiting to be applied. And the transformed evidence, by contrast, is used to initialize the core structure, the central structure of the processor, which is the ACS, the appraisal claim set. And that asymmetry sort of matters because basically evidence seeds the picture, and then ref values and endorsement are applied to the picture that is seed by evidence. And then you have the engines in the middle, the so-called match and augment, ACS match and augment box that basically repeatedly takes staged items, so items from the staging area, and if their condition matches the current ACS, then this algorithm takes the addition and augments the ACS with that addition. And that loop is this sort of the chugging piston of the processor. And when the loop is done, when the staging area is consumed, then the ACS is done, right? It can be made richer than it is, and it's taken and it flows out to subsequent phases, what we call it subsequent phases, that are relevant to the verifier in general, but are the quorum processor is not concerned with those, right? So these subsequent phases include appraisal policy evaluation and basically what ultimately becomes the attestation results for the underlying party. So I would say the three structures that you have to hold in mind in this picture are the ECT, which is the unit of processing, the ACS, which is the sort of growing picture, and then the staging area, which is the queue of the things that apply. And I think I will go through each of these in the next slide. So the ECT, the environment claim tuple. Please again interrupt me if you have questions, and don't worry about that.
I was just looking at the time and thinking, does it make sense to jump into this now, or this was just like a nice setup so we can lead into it next time.
No, okay. So then the previous slide here, the processing flows is the right place where to drop the pen and restart maybe next time.
Great. Well, thanks
Okay.
for letting me rip you into this meeting without much
Thank you
heads
for
up.
reminding me that I had a meeting at this time of the day. Because it wasn't in my calendar, so for reasons that are still to be determined, I didn't know that I had this meeting today. But thank you again, and I will follow up on the next in a couple of weeks, or I don't know whether there's anything else queued already.
No, I think
Greg?
you're on it. The next one.
Okay, perfect. Okay, I will try not to forget that I have a meeting that day. Okay, thanks very much, everyone.
Thanks, Thomas.
Bye-bye.
Thanks.
Thanks, everyone.
Good. Have a good couple weeks, everyone.
Cheers.